Continue working on your scene from the last movie, or open the file cityblocks.roads.intersections.max if you need to catch up. The spline workflow used in the last movie resulted in bad topology when converted to a mesh. Delete the Edit Poly modifier to go back to a spline level. The existing spline provides some good key points to use as snap points. As mentioned in the last movie, one of the better workflows, or at least one with the greater flexibility, starts by building road intersections. Road intersections are more than just a square mapped with an asphalt texture. To do it properly, you have to account for various textures, including line markings for pedestrian crossings, lane dividers, and stop lines. You'll start with the center intersection and work your way out. Before you do, though, consider what kind of textures you need and how much variation you want to bring to your project. Road textures with markings can certainly be bought commercially, but they're also fairly easy to create in a Paint program. All you need is a base asphalt texture, and then you can build multiple layers with various markings. You can play with different blending modes and opacity levels to create markings that work for you. For this tutorial, you get a dozen or so road textures to choose from, although you won't be using all of them. You can also use them as a base to edit and enlarge a library. Take a look at the center intersection and consider what it should look like. It is clear that the main intersection is shaped like a square, and that square will just have an asphalt texture and no markings. However, building lots and sidewalks are usually curved or chamfered, so you may want to expand that asphalt-only texture a little bit like so. After that, you would want to consider the pedestrian crossings, which, in our project, are represented by two parallel lines. Finally, and also part of the intersection, you want to include the stop line markings. This, in effect, becomes your intersection. You can then use this template to create other intersections in your scene, including those with different markings. So, let's take a look at creating this template. At this point, you can select and hide the main reference plane. It's enough to work with the reference plane you created earlier. If you need to change the swire color to see it better, feel free to do so. Zoom in closer to see the intersection better. With Snap Mode enabled, create a plane where the roads intersect. It should read 14 meters by 14 meters. Also make sure the divisions are set to 1. As explained earlier, you need to expand this to favor the curved or chamfered lots and sidewalks. Copy the intersection lower and change the length to 3 meters. In this case, 3 meters represent the chamfer value you will use for the sidewalks later. Using endpoint snaps, relocate that strip of asphalt right below the intersection. Make a copy of that strip of road below the current one. This one represents the pedestrian crossing and will be mapped differently. Finally, copy the main square intersection below the pedestrian crossing. This one will be used for the stop lines at the end of a road stretch. It too will be mapped differently. Next, you take a look at mapping these elements before creating the 3 remaining extensions. Open the Slate Material Editor, right-click next to View 1 and create a new view, name it Roads. Drag in an Arc and Design material. This typically works best with the Mentoray renderer. Double-click the material and set the template to Matte Finish. Asphalt doesn't need to be shiny or reflective. From this point on, you can collapse the channel list. You only need to deal with the diffuse channel. Holding Shift down, create 2 more copies of this material by dragging it in the viewer. With a right-click, add a standard bitmap node and browse and select the file named rdinter JPEG. You can also drag and drop it in the material viewer using Windows Explorer. Connect this bitmap to the diffuse color map channel of the first material. Now, select the main material node and enable Show Standard Material in Viewport. This makes it possible to see the texture in the viewport. Repeat the procedure to apply the bitmap rdcrossing.jpg to the second material, and the bitmap RD two-way double stop JPEG to the third material. Apply the first material, asphalt only, to the intersection and the first extension planes. Apply the second material, the one based on the pedestrian crossing, to the second narrow strip of road. Finally, apply the third material to the remaining square plane, this one representing the stop marking at the end of a stretch of road. Instead of repeating the procedure in the other three directions, you will simply rotate and duplicate what you have created so far. Select the three parts you need to duplicate, all but the main intersection. Press A to enable angle snap. You may also want to temporarily disable snap mode, S on the keyboard. Choose the Rotate tool from the main toolbar or from the quad menu. By default, the selection rotates about the center point, but you need to rotate it about the center of the world at 0, 0, 0. Set the coordinate system to World, and set it to Use Transform Coordinate Center mode. Now you can shift rotate 90 degrees and choose to create 3 copies of the selection. You still need a few bits in the corners, or else you may get holes between the roads and the sidewalks. Copy and adjust an asphalt-only part into a 3 meter by 3 meter element. Position it properly, and then turn it into an editable poly. Switch to Edge mode and use the Cut tool to add a diagonal edge, in essence turning the square into 2 triangles. This means that you can now select the unwanted triangle and delete it. You can now exit sub-object mode and use the Rotate trick to add the remaining 3 triangular corners. This takes care of the intersection, but at this time it is still made out of different parts. Select the center square and turn it into an editable poly. Next, use the Attach tool to attach the remaining road parts. When you try to attach a road part that has a different texture, you get a warning. Use the default Match Material IDs to Material and click OK. What this option does is that it rearranges material IDs on the various faces and combines the various materials into a multi-sub-object material. In the Material Editor, delete all nodes in the viewer, and then use the Material Picker button and click the intersection in the scene. A new multi-sub-object material is created in the Slate Editor that is based on the 3 materials you designed earlier. What's more, if you check your object at a polygon level, the material IDs have been set to take advantage of the multi-sub material. Polygons on ID number 1 are assigned to submaterial number 1, ID number 2 on submaterial number 2, and so on. This becomes very useful later when you need to switch between various textures for various road markings. You're almost ready to move on to the next movie, but a couple of things remain. First, go into vertex mode and note that vertices are not welded yet. even though they are in the right place, considering how you created the objects. Select all vertices and note that there are 64 selected, where there should be quite a smaller number. Click the Weld button to fix that problem, and end up with 28 vertices instead of 64. And exit vertex mode when done. Give the intersection a name, although this is less crucial as you ultimately will attach all road parts into one infrastructure. Zoom on the intersection. You'll notice one more problem to resolve. The pixel ratio for the asphalt is off between one area and another. To resolve that, you need to tweak the object using Unwrap. With the intersection selected, apply an Unwrap UVW modifier. Go to Polygon mode and select the center square. Remember the F2 key that toggles shaded selection on and off. The center square and the adjacent polygons have a plain asphalt texture with no markings, so it makes sense that they should be mapped together. Click the Grow tool to select the adjacent faces. You may want to temporarily disable shaded mode, F2, in order to see how mapping is going to affect this area. Also, open the UV editor. You'll need it to adjust the mapping. Click the Planar Map button and then click the Z button to map the selected faces from top. The selected faces are mapped to the bitmap texture, and now the pixels on the selected area are uniform. Exit Planar Map mode. Select one of the pedestrian crossings. Currently, it is mapped to a square bitmap, distorting the pixel aspect ratio. Zoom back in the UV editor window and make sure Freeform is selected. Hold Shift-Alt to constrain the scale horizontally and scale the cluster so that it is about 3 times as wide as it is high. This should make the asphalt pixel ratio work better in the scene. To adjust the other pedestrian crossings, start by copying the current cluster's mapping coordinates. Then, select another crossing and simply paste the coordinates onto it. Repeat until all 4 crossings are corrected and exit the UV editor window. Finally, convert the object to an editable poly again to bake the mapping coordinates. Save your file. In the next movie, use this template to create other intersections.